I'm Salman Ibn Yunus, back here again with another video. In this video I will talk about heuristic search algorithms. So what are heuristic search algorithms? So heuristic search algorithms are informed search techniques that uses a heuristic function to estimate the cost from the current state to the goal state. This estimates guides the search, making it more efficient than uninformed search methods. They are commonly used in pathfinding, game AI, and robotics. So in this tutorial, I will also show two popular heuristic algorithms, A-search and greedy-based first search in an interactive way. First of all, we can also explain the heuristic search algorithm a bit. So as I said, examples of heuristic search algorithm are such as A-star algorithm. So it is defined as a heuristic search algorithm is defined as a best first search method that is a combination of cost function and heuristic function to find the optimal solution in a state space by expanding nodes with lowest estimated cost. A heuristic is the most common sense. It is a method involving adapting the approach to a problem based on previous solution to similar problems. These approaches aim to be easily and quickly applicable to a range of problems so as to find approximate solutions quickly without using the time and resources to develop and execute a precise approach. The principle of a heuristic can be applied to various problems in mathematics, science, and optimization by applying heuristics computationally. Heuristic search is a class of method which is used in order to search a solution space for an optimal solution for a problem, as I have already said. The heuristic is some method to search the solution space while assessing where in the space the solution is most likely to be and focusing the search on that area. It is often possible to model the process of solving a problem as a search through a solution space starting from the initial possible solution, with a method or set of rules dictating how to move from one possible solution to another. This method or rule set must be applied repeatedly in order to eventually satisfy some goal condition which indicates that a solution has been found. So in this example we will show two examples for A search and greedy based first search. So what is greedy based first search? So greedy based first search is a heuristic driven algorithm that prioritizes the exploration of nodes based on their estimated cost to the goal. The algorithm selects the node that appears to be most promising according to a heuristic function Hn, which estimates the cost from node n to the goal. For example, we can imagine a robot navigating a grid from start point to a goal. A star would use the distance already traveled and an estimate of the remaining distance, example straight line distance, to choose the most efficient path. So how it works? The algorithm starts with the initial node and evaluates its neighbors. It chooses the neighbor with the lowest heuristic value Hn and continues the process. Greedy based first search does not guarantee finding the optimal path, as it can sometimes get trapped in local optima by always choosing the path that looks best at the moment. Okay, so let's see how it works in a simple example. This is an interactive tutorial or simulation that I'm showing now. So let's start somewhere here, and then I will set the end point somewhere here. So the green is the starting point, green block, and the red block is the end point. So let's see if I can set some wall. Okay, so then let's run the algorithm. So as you can see, it has reached the path in a very short time. So in this case the path length is only 16, which could have been much larger if you have used other algorithms than heuristic algorithms. So this is pretty faster in this case. So what is A star search? A star search is one of the most widely used informed search algorithms. It combines the strength of both uniform cost search and greedy best first search by using a composite cost function, which is fn equals to gn plus hn, where gn is the exact cost from the start node to the node n, and hn is the heuristic estimate of the cost from n to the goal. For example, if a GPS is trying to find the shortest route to a destination, greedy best first search might choose the road that seems to head most directly toward the goal without considering the overall distance. So how does S star search algorithm work? It evaluates nodes based on the sum of the path cost and heuristic estimate. The algorithm ensures that the path found is both the shortest and most cost effective, provided that the heuristic function is admissible, that is, it never overestimates the actual cost. Let's see example of A star search algorithm. So I'm starting here and now setting the endpoint somewhere here. Okay, let's run the algorithm. So as you can see, it is pretty faster and the path length is shorter than the greedy best first search. So this is also pretty faster than other brute force algorithms like DFS or BFS. So there are also other heuristic search algorithms such as iterative deepening A star or IDA, beam search, and others. So probably we will discuss about them in some other video next time. So as you can see in this interactive tutorial, I am also giving some definitions as I have explained it already. A star search is an informed search algorithm that finds the shortest path between a starting and a goal node. It uses a heuristic function to estimate the cost to reach the goal. A star is optimal. That is, it finds the shortest path and that is, finds a path if one exists. If its heuristic is admissible, never overestimates the true cost and consistent. It evaluates node using this equation fn equals to gn plus hn, where gn is the actual cost from the start node to node n, and hn is the estimated cost heuristic from node n to the goal node, and fn is the total estimated cost of the path through node n. And greedy best first search expands the mode that is closest to the goal as estimated by the heuristic function hn. It prioritizes exploration based purely on the heuristic, making it very fast. However, it is not guaranteed to find the shortest path and can get stuck in local optima. It evaluates node using fn equals to hn. Difference is A star search evaluates node using fn equals to gn plus hn, and greedy best first search uses fn equals to hn. Heuristic function or Manhattan distance. So for this read, we use the Manhattan distance as the heuristic function. It calculates the sum of the absolute difference of the coordinates of 2 points, where hn equals to x absolute value of x1 minus x2 plus absolute value of y minus y2. This heuristic is admissible for grid-based pathfinding where movement is restricted to horizontal and vertical steps, no diagonals, as it never overestimates the true cost. So there is a couple of other heuristic functions as well, which we will discuss probably in some other video. That's all from this video. Thank you for your time, patience, and understanding.